is Addie Atkins. I am a territory sales manager here at TimberHP. I cover Massachusetts and Vermont. We are excited to put this group together. Jason Todd here, also from TimberHP, is our Director of Building Science and Industry Support. I bounce a lot of things off Jason all the time when they get thrown at me from the field. In our panel discussion today, we've got Chris Mazzola. Chris and I work a lot with he's a HERS rater, and so lots of new things happening in Massachusetts. We'll touch on that towards the end, but we're excited to have Chris here. We've done lots of presentations together over the past year. And then Ryan Mers from ResNet, Program Director. He's going to start us off today with kind of the big picture, what's going on, what is HERS, what is ResNet, how does this all play into our everyday lives in the building industry. We also have Alex Donnelly, our inside support. He is going to help answer questions. Feel free to put those questions in the Q&A. Introduce yourself in the chat. We want to keep this pretty open and flowing. So if you've got questions, throw them out there. We'll do our best to answer as we go. Before we kick into the HERS rating ResNet content today, I am going to just walk us through, introduce you to TimberHP if you are not familiar. We'll just hit a couple slides here, give you a quick introduction, and then we'll jump into more topics. So TimberHP, we are the first U.S. manufacturer of wood fiber insulation. We are making these products in Madison, Maine. We are using the wood chips that are the residuals from the lumber mills in Maine, and we are creating insulation products with them. So we have a blown-in product, Timber Fill, that can be dense packed or blown into attics. We have the Timber Bat product, which is out into the market. That is a semi-rigid, flexible bat that friction fits into the wall cavity. We have that in a variety of sizes, designed for wood stud or metal stud applications, thermal and acoustical bats, on the ground at our distribution centers. Timber Board is our third product. That is going to come out as a square edge board in 2025. We're still dialing in the details on that product line, but as we complete that, you'll be able to do your whole wall assembly, vapor open, airtight, and use your wood fiber insulation in the interior wall cavities and exterior for that continuous insulation on the outside. Some of the benefits of using TimberHP products, wood fiber insulation, is that this is one of the only options out there that is carbon storing and scalable. We're really working to prove this out in the Mid-Atlantic North. New England being our key focus right now in my market. But what we see the ability to scale this across the country and have a cost-effective carbon storing high performance product that can go in every build. From the high performance side, we have a vapor open product that has a great R value, great acoustical properties, and those vapor open properties are going to allow you to move humidity, vapor out of the building. It's going to reduce your risk to have mold and mildew and moisture that builds up in that wall cavity. It is a non-toxic, safe product to work with. We're using softwood wood fibers and a borate solution. So very easy to handle, easy to work with, nothing that's off-gassing, no formaldehyde, good indoor air quality for the occupants that are going to be living and working in these buildings, and safe for your installers to be able to handle. Class A flame spread with the Timber Fill and the Timber Bat. We do have 1 hour and 2 hour firewall assemblies in our ESL report, and we can get you that technical data. So we've got the Timber Bat, the Timber Fill, and then coming soon, the Timber Board for that exterior product. And as we are diving in today to the HERS rating and potentially decarbonizing our buildings, we just wanted to hit on a little bit more of that wood fiber insulation. How do we get to that carbon negative story? And that basically comes from the natural process. You've got your tree growing in the forest, is pulling in carbon dioxide through photosynthesis. When that tree gets cut down to be milled into whether dimensional lumber, moldings, whatever wood product they're making, those products go into a house. The residuals or the leftover from that manufacturing is either going to get burnt off, releasing the carbon, or left to rot and decay and releases carbon. But if you can take even those residuals from those manufacturing processes, make it into another high performance product that then gets put into a wall and used in the home, then we are storing that carbon for another, 100 years in that structure. We have done some initial life cycle analysis with our plant, but as we are a new manufacturer, we have, almost a year under our belts with the timber fill and less than a year with timber bat. We are still dialing in some of our numbers, but this was an initial life cycle analysis, just showing that the wood fiber insulation is coming in carbon negative. So our mill is an old paper mill on the Kennebec River up in Madison, Maine. We use 80% of the power comes from the hydropower of the dam right by the river. And we're using these wood fibers, and we've got the carbon storing nature of the wood. So compared to some of the other insulation materials that are on the market, when you're taking a high performance product that's carbon negative, it is a win-win in the insulation world. I just added this slide into, this data comes from the Rocky Mountain Institute, a report that came out in July. It might be a little blurry, but we could send this to you if you'd like to see these details up a little closer. But this is again, the carbon footprint of different insulation materials. Some of this data comes from beam, some of it comes direct from different manufacturers. You can see those carbon storing products there are hemp fiber, cellulose, wood fiber bat, hempcrete, wood fiber board, and cork. Those bio-based products have that ability to do the carbon storing. Some of these are based on an average of different products that are available in those markets. And as we develop as a company, we will get our EPD, our life cycle analysis, and our EPDs to the market. We did just recently receive a grant from the EPA to work on that, which as a startup is very much appreciated, and will help us get that info to the market for everyone to see. But we are excited about TimberHP and about bringing these bio-based products to the market for you to use in your house, bringing high performance products that can make a difference in our built environment and our overall global climate. All right, so that is the quick on TimberHP. We're happy to answer lots more questions, but feel free, Ryan, to jump in and show your slides.
Yep, thanks, Addie. I will get my slides pulled up.
And while you're getting that set up, Addie, if you could figure out how to add me as a host to some administrative stuff I can do in the background. Alex needs a little support.
Gotcha.
All right. Hey, everyone. I'm Ryan Mears with ResNet, and I'm going to be going over kind of a high level of, what are HERS ratings, why are they important, what additional value can they bring, and then at the end, I'll touch on our new HERS carbon index, which is an operational carbon index. So when you combine an insulation product that has a negative embodied carbon with the ability to also impact your operational carbon, it's definitely a win-win. So you'll see how some of that ties in as I go through. So first of all, for those of you that are not familiar with ResNet, we're a national nonprofit. We were founded in 1995. We are also an ANSI accredited standard development organization. So we develop standards for energy efficiency, which relates to the HERS index, water efficiency, which is our HERS H2O program, and then our new carbon index. And we also have standards for inspections and testing for things like envelope leakage and duct leakage. We're also a home certification organization for WaterSense, Energy Star, and the Zero Energy Ready Home program. And we have a national network of about 3,000 certified home energy rating professionals. So the HERS index at its very basic level, it's based on ANSI standard 301 that ResNet develops jointly with ICC. It's an index scale, so each 1 point change on the scale is equal to about a 1% change in energy use. The lower number means a better score. It's kind of like a miles per gallon rating for a home. A score of 0 would be a net zero energy home. That home would have to have some amount of renewable energy to get there, and then a 100 is the reference home that the rated home is compared to. And that's based on the 2006 version of the IECC, as well as the federal equipment efficiency standards that were in place at that time. At its very basic level, when you're doing a HERS rating, you're comparing the rated home that could be an existing home or a home that is being designed for construction, and you're comparing that home against the reference home. Now, the reference home gets automatically generated in software. ResNet accredits 3 different software programs to do HERS scores. And that reference home establishes the baseline, which is based on that 2006 code, and then scores a 100 on the HERS index scale. And then anything in the rated home that is more efficient than the reference home is going to reduce your score. And the reference home is always going to be a geometric twin of the rated home. This is a map that we produce each year, going all the way back to 2016. And this in particular is looking at single family and duplex homes, and the percentage of homes that were HERS rated in each state compared to the number of permits that were issued for 1 and 2 family dwellings in each state. And you can see Massachusetts has come out on top, and has for many years, at 98% of all new homes there receiving a HERS rating. We had nationally about 360,000 homes rated last year, which is about 30% of all single-family homes that were permitted in 2023. And there's about a half a dozen states that come in at above 50%. And there's a number of different things that drive this, including the energy code that's in effect, utility programs, and also some builder competition and other incentives, and I'll talk about what some of those incentives are related to HERS ratings. When we talk about the HERS rating process, there's kind of 3 primary steps. The first is a projected rating. So when we're talking in here, most HERS ratings are done on new construction. So most of what I'm going to talk about is going to be related to new construction as opposed to renovations or ratings on existing homes. So first is a projected rating. This is going to be based on your plans and specs. It's going to provide you a HERS index score based on what the anticipated design is. This is often used for the issuance of the permit. You would submit this with your permit application. And then there's a pre-drywall inspection. So post-insulation installation and pre-drywall installation, you're going to have an inspection that looks at the insulation R values. It's going to grade how well the insulation was installed on a grade of 1, 2, or 3, with 1 being the best and 3 being a not very good installation. And then it's going to look at some air sealing, windows, HVAC equipment, anything that's been installed already. Then and it's important to note that pre-drywall inspection is mandatory for HERS ratings, as well as Energy Star and Zero Energy Ready Home. Then once the home is just about complete, the final inspection is going to test for your envelope tightness, your duct tightness, and then that's also a mandatory inspection for Energy Star and Zero Energy Ready Home. That final inspection is going to catch anything that was not available to be inspected at the pre-drywall phase as well. So the energy rating index is something you might be familiar with, often referred to as the ERI. This is the ERI and HERS are essentially the same thing, but there are some nuances as to how the ERI is used in the energy code. So standard 301 is essentially the energy rating index. When it gets referenced in the IECC, we refer to it as the IECC ERI. And the code can change stuff. So what's in the IECC in terms of ERI can be different, meaning you could get a different ERI score versus your HERS score because the code can change things as it relates to the standard and the scoring. So the ERI has been in the IECC since the 2015 version, and every version, including the most recently published 2024 IECC that was published just a few weeks ago. It has changed in each of these versions. There's been changes to the ERI path, but generally the ERI and HERS are going to be similar. We also we talk a lot about the path to net zero and ultimately what is required for the energy code to get there. How can we get there with HERS ratings? So this is a chart that the Department of Energy puts out, developed by the Pacific Northwest National Laboratory, and you can see between 2006 and the 2021 code about a 37% increase in just overall efficiency of the code, and that modeling is typically based on the prescriptive provisions in the code. The 2024 IECC is expected to add maybe 5 to 7% additional efficiency beyond the 21 code, but we are getting to a point where, based on current technologies, the limit on most cost-effective efficiency measures is somewhere around 40. In the Northeast and colder climates, I think you can get into the 30s a bit easier. You can certainly, there are examples, I believe in Massachusetts, where you can get into the upper teens or low 20s on efficiency. That's not, I say cost effective because that's not necessarily something there's not a 100 home community that's being built like that. It's typically a custom home, somebody who's willing to spend more on a really good home that gets great efficiency. But as far as cost effectiveness at scale, you're around your kind of 40 upper 30s is typically where you're going to get at scale with efficiency. And then you've got to add in renewables to make up that difference to get you down to a net zero level. This is also a map that's produced by the Department of Energy through their Building Energy Codes program. This map is looking specifically at what level efficiency status each state is at when it comes to the IECC. So this does not mean that this particular version of the code is adopted, but this is the level of a code efficiency that each state is at. And you can see there's like 7 states that are under the 2021 code, about 20 plus states that are under the 2009, in some cases less than the 2009 efficiency levels. So for a lot of states, there's a big gap they need to make up, around 30% efficiency increases to get to the levels of the current energy code. And this is a big difficulty, and it's a real pain point for builders in particular when you talk about going from a 2009 efficiency all the way to a 21 or 24 code efficiency level. So there's a need for a more of a pathway to get to net zero, and the HERS index is one way that states can get there.
Hey, Brian,
Yeah, go
just
ahead.
real quick. There was a question that was curious about the percentage of HERS rating by state. California looked relatively low on your former chart, and then on that one, you were showing that, they're at a higher efficiency, but what's the difference? Are they not using the HERS system as?
Yeah, that's a great question. And I think this is, you've maintained my track record of every time I show that map of getting a question about California. So thank you.
Yeah.
That's a very common question I get. Why is often what they're saying is, why does California have so few HERS ratings?
Yeah.
And there is a difference between a ResNet HERS rating and what California calls a HERS rating. A California HERS rating is basically compliance with the Title 24 Energy Code in California. That's not something that we track at ResNet. We don't do compliance with Title 24. So the number you see in California is specifically the number of ResNet HERS ratings that were done there. So effectively, all those 5% of total building permits issued last year is builders that have voluntarily chosen to do a ResNet HERS rating, and they typically use that for marketing, for getting it into their real estate listings and things like that. And also it makes it available in our appraiser portal. So appraisers can use it in their evaluation to potentially get more value in terms of the home when it's sold. So those are all builders that are voluntarily using it. That number has increased. Actually, it's 5% is one of the highest we've had. It's been in the 1 to 3% range for a long time. But recently, the California Energy Commission basically said officially that ResNet HERS ratings can be done voluntarily in California. For a long period of time, they said that their state law preempted another rating program from working there. And anyway, long story short, ResNet HERS ratings can officially be done voluntarily by builders in California.
Hmm.
But it's not an energy code compliance path there. You still have to do Title 24.
Okay.
So speaking of kind of getting to net zero, this is kind of what I mentioned, going from a 2009 to a 21 or 24 efficiency level is really difficult for builders, especially when there's compliance paths in the energy code that really can't account for equipment efficiency. So in the 21 and 24 code, in the prescriptive path, there are ways you can start to account for equipment efficiency. But the reality is that the ERI path in the energy code is the only one that fully accounts for whole home performance, as opposed to just looking at, insulation values and window values when you're talking about a UA trade-off, or the prescriptive path that is basically follow the prescriptive R value requirements in the table to meet code compliance. So the performance, when we talk about getting to net zero, it has to be a performance-based approach. Getting there on the prescriptive path, as has been shown in California, is almost impossible.
Hey, Ryan, just for the benefit of the group, could you just touch briefly on prescriptive path versus UA and performance without getting too deep into the weeds?
Yeah. So the prescriptive path is basically, this is what's required by the code, follow it. And that means your R values, your windows, your duct testing, envelope testing, everything that's required in the code prescriptively. This is what you have to do. The UA trade-off is basically a subpath in the prescriptive path, which just looks at it gives a little bit of flexibility in trading off, say, more ceiling insulation for less wall insulation or floor insulation, or better windows for slightly less insulation in certain areas. It allows trade-off basically among insulation values, a little bit of flexibility. And then the performance path is similar to the ERI, but up until the 24 code, the performance path did not allow equipment efficiency to be considered. In the 24 code, that gets added back in, and then the ERI path has always been a full performance-based compliance.
Great, thank you.
So ultimately comes down to, what are the benefits of doing a HERS rating? So one of the things that really differentiates a HERS rating from an ERI is that when you do an ERI rating based on the energy code, there's no quality assurance required. Every HERS rating gets submitted to the ResNet registry and requires quality assurance oversight. So that's one of the benefits of HERS ratings. There's a number of other benefits that come with having the HERS ratings in the ResNet registry. So this includes being able to share that with real estate listings. ResNet does this. There's also organizations we share data with that also share that with various real estate listing platforms and multiple listing services. The data can also be auto-populated in appraiser software. So this is really going to launch in 2025. We now allow appraisal software companies to access our data so that they can auto-populate the HERS information into the real estate listing. And this comes into play with the new uniform appraisal disclosure forms that are going into effect, I believe in 2025 or into 2026. There's also, we have a resident appraiser portal. Any licensed residential appraiser across the country can access that portal for free and be able to do comps on homes that they're appraising within the portal. Freddie Mac and Fannie Mae both have a green mortgage-backed securities program, where essentially what this means is that mortgage companies that would typically sell their mortgage to Freddie Mac on the secondary market, they can get a premium on that sale now if the home has a HERS score of 60 or less for Freddie Mac, or if it's an Energy Star certified home to Fannie Mae, that's what's required for their program. So that's especially important to the national builders that have their own mortgage subsidiary, because it's a direct benefit to them as a company to get a premium on the sale of that mortgage. There's also the ability to track energy savings, energy cost savings, CO2 reductions within the registry. And then many builders also use the data within our registry for their sustainability reporting. They report on the energy savings, CO2 emissions reductions, and their HERS scores and things like that for their sustainability reporting. The HERS score is also a pathway to the 45L tax credit, so $2,500 for Energy Star and $5,000 for Zero Energy Ready Home, as far as the tax credit goes. The resident registry is also starting to be used more by code officials. This is especially true in Massachusetts and a few other areas where code officials want to ensure that that home has received the HERS rating that it says on the documentation. So they'll use the registry to search the address to find what the HERS score of that home was. And then as I wrap up with the carbon index, so the HERS carbon index is fairly new. We've always calculated carbon emissions within the ResNet HERS index and standard 301. Basically, there was a change just a couple of years ago to standard 301 that institutes a new calculation methodology for calculating operational carbon. So the carbon index is operational carbon. It's not embodied carbon. There is a standard being developed for embodied carbon now, but there's a lot of new potential when it comes to utility programs using the carbon index, especially in states that have very aggressive and very efficient energy codes, because those utility programs have less and less room to be able to claim savings for like above code programs. So we see a shift coming from efficiency programs toward carbon reduction programs, which make a lot of sense for electric utilities in particular, because the reference home for the carbon index is all electric. So the use of fossil fuels will obviously, as it should, increase your carbon index score. And then here's just a quick example of a carbon a HERS rating certificate with both the carbon index and the HERS index. And the carbon index is required to be included with every HERS rating. So any home that gets a HERS rating will also have a carbon index.
Right.
And that's it.
Great, thank you very much, Ryan. Just a quick question on the carbon index and the future work. When we talk about embodied carbon, do you expect that to be separated in how it's documented or presented, or just kind of rolled up into a new and improved carbon number?
Yeah, so I think it will start out initially. I think we will still have the CO2 index for operational. We will have, I think it's still kind of yet to be determined if the embodied carbon will be an index or simply a number that gets calculated. But where I do see it going is an overall carbon, right? So particularly because There are some things that are going to be really great on embodied carbon, some things that are going to be worse on embodied carbon, but good on operational. So I see it actually eventually being turned into an overall carbon score that incorporates both embodied and operational carbon.
Great, great. And just a quick follow-up from reading the audience about carbon, if there's a carbon checklist or any links or additional information around that and how that's calculated currently.
For the carbon index calculation, yeah,
Yeah.
the CO2 index calculation is, yeah, it's included. Um, it's actually not very exciting. It's part of our standard. So the actual calculations for that are part of standard 301. So if you go to resnet.us and click on the About Us tab, you'll see a standards link there, and it will be you'll it was basically a CO2 index addendum to standard 301. So the calculations are in there. They're not real exciting, but they if you want to dig into them, yeah, they're included in standard 301.
You never know what excites people.
I know.
And then just one other follow-up question, is LEED getting involved in HERS rating? Any connection with the LEED system?
Lead for homes, particularly, I didn't say it at the beginning, but ResNet is exclusively residential. So anything from single family to high-rise multifamily is included. Not commercial though. So if you're talking kind of lead, which is more commercial focused, lead for homes, yes. Certainly, there's I believe it's been included for a long time and still is a HERS index option within the lead for homes program for on the energy efficiency credits.
Great. Thanks, Ryan. Feel free to jump back in at any time, but I think we'll kind of shift a little bit towards Chris and kind of talk about what's going on in Massachusetts. As you saw from Ryan's chart in the US, that there's a high concentration of HERS rating that is happening in Massachusetts. So Chris, do you want to give us the high level, how we got to where we are here in Massachusetts, what we're doing differently than a lot of the other states?
Yes, I
Hey,
will.
and Chris, sorry to jump in real quick, but maybe we kind of did this early on, but if you want to talk a little bit about where you're coming from, what you do, what your company does in context, that might help.
Sure. Yeah. No, absolutely. Yep. So I will share my screen. Is that okay? Does that look right, Addie? Okay. So my name is Chris Mazzola. I am currently the production manager for Home Energy Raters. We are a home energy rating company based in Eastern Massachusetts, Sagamore Beach, just before the bridge to the beautiful Cape Cod. I have been a HERS rater for 19 years and 8 months. I am almost to my 20-year mark. Started in the industry before HERS rating was a code compliance path. Massachusetts got to where we are in that high percentage of HERS ratings because we have a very, very robust utility funded incentive program that uses the HERS rating as one of their main metrics to generating that incentive. So our Mass Save program, is a collective of 7 different utility companies across the state, and and it's facilitated by a single company, ICF. So early on, back in the the late like 1998, 99, Mass Save was paying HERS raters to do blower door testing on homes and giving builders an incentive to let us do it. So that built that foundation and the relationships and really the early stages of the educational process on the values of a HERS rating to builders. As the IECC kicked in 2009, IECC kicked in and became a code compliance option. HERS rating what gave builders the ability to value engineer their projects. So we would compare the home to be built to the prescriptive table in the IECC, 402.402.1.3. And then we'd say, well, we only need to get to a HERS 75. So you model the building as designed, and back then maybe it came in, at a 68 or a 58. So we were able to reduce our values and change insulation, change window U values, the performances of different mechanicals to save the builder money and model to the bare minimum. We do the same today where the prescriptive R values in the current 2021 IECC is an R60 in a roof assembly, an R30 in a wall assembly, 19 cavity in a foundation wall, or 15 continuous. So we can look at the costs of going to an R60 compared to using a much better window, a much lower U value window, knowing that the window is the weakest link in your thermal envelope. It's always been the weakest link. It probably will always be the weakest link. So the better the performance of the window will increase the overall U value of your wall assembly. Reduced framing factors will increase the overall U value of your frame, your wall assembly. So that's what we look at is, it's kind of it's a puzzle. Every house is a puzzle. And it has the same pieces, but for some reason they'll fit together and end up with a different picture. It just depends on how you want to put the pieces together. So, my screen share, I typically don't like PowerPoints. I'd rather just talk and have conversations with people, because I think specific scenarios and discussing people's individual projects and problems and coming up with solutions is far better than bouncing through a bunch of slides. But this is one of the documents that we give our builders on the front end, just to kind of give them a beginning idea of where they should be heading for their project, knowing that in Massachusetts, if they want to use gas, they want to use propane, there's a HERS score hit. They have to get to a HERS 42, but there's a way to get there. And it doesn't necessarily mean an all closed cell spray foam house. Because again, we go back to every house is a stack of puzzle pieces, and how we put them together, it's however you want to meet your expectations as a designer or a builder. So we always start with the expectation that the home is going to be all electric. The state of Massachusetts has very robust decarbonization goals, climate goals for 2030, for 2050. In the Mass Save program in the Department of Energy have expressed their expectations for decarbonization. So we always try to get builders to go all electric. It is the easier path. The efficiency ratings are much higher. But the key points are when you're looking at heat pumps, air source heat pumps, cold climate air source heat pumps, we need HSPF 2 ratings of 10 or higher for two reasons. One, 10 or higher performs better than the UDRH that Ryan talked about earlier. And an HSPF 2 of 10 or better will qualify the home in Massachusetts for alternative energy credits. And based on the HERS score, those can be anywhere between 40 cents and $1 a square foot, a conditioned floor area. So it's an extra incentive for all electric homes on top of the robust incentives that you can get through the Mass Save program, which in this current new program that actually starts in 5 days, a base all electric home will get an incentive of $7,500. And then there's a few other riders for programmable thermostats and hybrid heat pump at water tanks and induction cooking. So you can fairly quickly get to the $8,000 range. Then you add on the AECs, and then with a little extra effort, very little extra effort, you can get to the Energy Star 3.1, and those incentives start to grow exponentially. And you layer on again the 45L tax credit of $2,500. So that's really one of the biggest reasons why we have such a high percentage of HERS ratings in Massachusetts, because of the incentive, because historically we've been doing them for a long time. And then really the second biggest, maybe it's the biggest, is our building code. 300 towns in Massachusetts have a stretch energy code and a specialized energy code. Both require a HERS rating. There is no prescriptive option. You have to hire a HERS rating, a HERS rater. Our base code, our 225 CMR, our 2B signed 10th edition, hopefully soon in the next month, defines a HERS rating as the ERI path. Just to go back, to the kind of the triggers to get us to that HERS 45 or 42. Windows are super important. In the efficiency of the heat pumps are obviously super important.
Hey,
number three. Oh, go ahead.
Yeah, Chris, just along those lines. So HSPF is the heating seasonal performance. So this is the efficiency of the unit.
Yep.
And so what it sounds like you're saying is that with this all electric option, as they're trying to sort of direct people in that capacity, they're electric based equipment, getting us off of the mixed fuels, fossil fuel based. And it looks like the envelope components in particular are a little bit more lenient in this case, and
they are
biased towards insulation. I'm interested. What is that framed walls 21 plus, 49 plus look like? And compare that to the stuff if you were to hold on to your high efficiency but fossil fuel based appliances.
Right. So I'll digress just a little bit first.
Sure.
We, as a HERS rating company, we do just over 2,000 HERS ratings a year. One of the largest in Massachusetts. We may be the largest in Massachusetts. I defer back to Ryan for that. It has been, not in recent memory can I remember a time where I've needed to model a home with more than a R21 an R21 above grade wall, regardless of the insulation type. So in most cases, our default in just about every HERS model we do is an R49 vaulted ceiling. So the roof line, so a hot roof, always go to the hot roof.
Yeah.
R21 insulated wall with usually a bat. Historically, it's been a fiberglass bat. And then typically in Massachusetts, we do uninsulated basement, so it's the frame floor. So it's an R30 bat, depending upon the joist, whether it's a true 2x10 or if it's an I-joist, a manufactured I-joist. The insulation can change a little bit. I-joists need to be fire rated, so if they're not fireproof, if they're not dipped, you would need mineral wool. You need to fire rate that assembly. So usually it's 3.5 inches of mineral wool, and then depending upon the depth of that I-joist, it'll be an R19 unfaced, or an R21, or an R30, depending upon the depth of the cavity. Yeah, I mean, we always try to push the thermal envelope out as far as we can in any house. We want to get as much of the mechanicals, as much of the distribution systems of the house inside that thermal envelope. So ductwork of the heating system, the cooling system, the balanced ventilation system, obviously domestic hot and cold water piping, we always want inside the thermal envelope. And we want to insulate everything, because as we get to these really low infiltration homes, these sub 1.5 ACH homes, we're constantly battling relative humidity. So there's a huge need for everything to have the ability to breathe and dry to directions.
So for the benefit of the group, what is the code cycle for Massachusetts that you're required to follow? And then maybe touch on that stretch code a little bit too.
Sure. Yep. So currently we're under the 2021 IECC, soon to adopt the 2024. We have a base code, which currently we're quasi under the 9th edition, the 10th edition of the building code. So it gets complicated. I'll try to keep this simple. The 9th edition of the Massachusetts Building Code, which is the 780 CMR, is what most of our stretch and opt-in codes refer to. We will soon have the 10th edition, which simplifies some of the confusion that the state created in the opt-in, these new specialized stretch codes, revolving around like renovations and additions, and the size of an addition or the level of the alteration where a HERS rating has to be, which triggers the need for a HERS rating. So the current verbiage is an addition or an alteration of 1,000 square feet or more would trigger a HERS rating on the entire house, which means the entire home, including the existing, would have to be brought up to code. Very similar to the FEMA floodplain laws in Massachusetts, where if you're doubling the size of the house or renovating it to more than 50% of the value, you have to bring the whole house up to code. Unfortunately, when the DOER stepped in and began writing codes, they didn't have the historic reference to duplicate some of the existing codes to make things easier, to kind of clarify the verbiage. So we ended up with some very complicated, weird codes, but we should have much better clarification in the next few weeks on some of these things. essentially what the stretch code, the stretch code in Massachusetts is one of the 5 parts of the Massachusetts Green Communities Act. In the adopting the stretch code along with 4 other metrics allows a community, a municipality, to apply for competitive grant money through the Department of Energy, which is funded through the Mass CEC. So towns can get grant money every year to upgrade the heating system of the library, upgrade the domestic hot water, or the heating and cooling system at the fire station. Change the chiller out at the town hall. And all this money is available because of the increased efficiencies of the homes being built in their town. And it's based on population. So the big cities get a lot of money, but they need a lot of money. So it makes sense. There are 40-ish towns in Massachusetts that have yet to adopt the Green Communities Act simply because they're just too small. They don't pull that many building permits. They wouldn't get that much money in competitive grant. So it just doesn't make sense for them to take on the responsibilities of the other things they would have to do. But, for the bigger municipalities, it does make a lot of sense.
Yep.
And then when you add in municipalities like in Massachusetts, like Somerville and Cambridge and the city of Boston, Brookline, Newton, where their climate action network committees are very robust. They're very strong. They have very progressive energy committees, and they're pushing, for a very low, carbon, very low energy code in their towns to fight climate change.
Sure.
Um,
We had someone just bring up in the chat that Michigan is in a 3rd pilot phase with HERS rating, and not to derail you from what you're doing, but I'm just wondering if maybe for you or even for Ryan, if how unique is this scenario that Massachusetts has in place with HERS ratings, and it seems like it's a very robust part of the code system, if you will.
Yeah, I can't necessarily speak just to the Michigan one, but there are many utilities across the country that incentivize HERS ratings. They will typically set a target score, and then we see rebates that often go directly to the builder of anywhere from $500 to $6,000 or more, depending on the state. But yeah, there are many utilities that have those types of programs that will incentivize builders to get certain HERS scores. And then it's kind of similar to Massachusetts. We see states, including Texas, where they have a HERS code compliance option. So the Texas statutes basically put in a couple of years ago a HERS option in the code that's available to builders statewide. It can't be preempted at the local level, and it sets a HERS target score, as well as some other kind of minimum requirements to comply with the state energy code. And we're seeing that similar practice start to pick up in other places. Las Vegas recently passed something similar to this, basically for all of Southern Nevada. So it is getting more common, and the states and jurisdictions are seeing it as a pathway. Because as I brought up, going from 2009 to 2021 code is a big jump. So if you can meet them where they are now with a HERS score that's maybe equivalent or a little bit better than 2009 levels, and then set target scores, that go down, ratchet down every 3 years, which is what Texas has done, going through, I think, 2030 or something like that, and Southern Nevada as well. It gets them on a pathway to get to those 2021 levels or eventually net zero without having the pain of going strictly from a 2009 to a more recent code.
Yeah, quite a jump. Thank you. Thank you, Ryan and Chris. Sorry to interrupt. Just as a little check-in, we're less than 5 minutes out to the top of the hour, so you could certainly talk a little bit about some of the other performance metrics here and how that all relates. But then also let you know we had a question just about the rating, the cost of a rating is, and how that might be done by square footage or otherwise. Maybe we could add that as well.
Yeah, I'm probably not the best to speak about that. We don't, we
No,
don't
sure,
really.
sure. No, I was thinking maybe Chris might have some
Yeah,
insight,
Chris can give a,
methodology around
yeah.
that.
Yeah, I mean, nationally, I can say, and I think Ryan probably will agree that the cost of a HERS rating is dramatically different on the West Coast or in the Southwest than it is in the Northeast. I will say that I am not an a la carte rater, so I have a set fee. So I charge $1,850 for an all electric home and $2,250 for a fossil fuel home. And the only reason those two are different is because there is a mass save rater incentive to the rater, so a subsidy. So I will deduct that subsidy from the average cost of a rating in Massachusetts is about $2,250. Renovations and additions, a full gut rehab on a home, we charge $1,850. It's more work, but again, the mass save incentive to a rater is more. So again, it's part of a lot of what we do in our pricing and how we operate in Massachusetts is, obviously guided directly by ResNet and our MinHERS standards, but also in Massachusetts by what Mass Save is offering. And that's we're always trying to optimize the incentive and the value of the home and the built cost through the HERS rating.
Great, thank you.
Yeah, I would just add the only variation that I see is also between the volume that a rater's doing. So if they're working with a production builder and that builder's going to put in 1,000 homes in a community and maybe they have 6 floor plans, that being able to model one floor plan and then those floor plans may have just slight variations. It's easier than developing an entirely new model. And when you can go to one community and do 5 inspections in a day and not have to travel, across town to do that, it also reduces the cost. But that's one of the other cost drivers, and that largely impacts the high volume builders that are typically in the South.
Right,
Gotcha.
right.
Yeah,
And we do that to some extent. Multifamily building or obviously, like Ryan was saying, I mean, there are subdivisions in Texas that are thousands of homes. We'll have a development of a couple of hundred homes, which is that's great. That's huge for us.
Yeah.
And I will, based on the relationship we have with that builder, obviously, they would get charged differently, a lower cost because of the volume and the consistency of what they're doing. And
yeah, I imagine you're not rediscovering every time when you're
no,
repeat home, cookie cutter home.
Yeah,
Yeah,
like I
yeah.
said, Addie knows. Some dude long ago invented the wheel. I'll push that thing all day long. I ain't interested in changing the shape of that at all.
Fair enough. Fair enough. We are past. We're just a minute past. Happy to stay on for a little bit longer if there are any additional questions for the group, or if Addie, you have additional comments. But maybe give you the opportunity, Chris, to finish the original thought. You've got ventilation and infiltration up here as part of the whole package, and might be worth a couple of bullet points on that.
Yeah, I would. I'll just say ventilation. A balanced ventilation system is one of the most important aspects of any new home. Take one of the biggest triggers on getting to that low 40s score is the infiltration rate. It's getting that blower door as tight as we can. full disclosure, our sister company is New England Air Barrier. That is an airborne air sealant. I think it's fantastic. We use it on a lot of homes. We do 2 to 3 seals a day. We've been doing it for about 2 years. It's really quick. It's usually the day after they plaster the home is the best day to do it. But we can do it pre-drywall. We can do it pre-installation. It's a great product if you're looking to get your blower door down sub 0.5, 0.6, 0.5 ACH. The last thing I would say is in the new upcoming code, we believe there should be, we're praying, we'll cross our fingers that there will be an embodied carbon credit. So low embodied carbon homes will be allowed to have a higher HERS score for their code compliance in Massachusetts. And for an all electric home, that would be a HERS 45. And for a home with fossil fuels for heating, cooling, and hot water would be a 48. And, you know, when we're trying to get to that low 40 score, 3 points is huge. That is huge. So, you know, the movement, like Ryan said earlier, the movement is toward decarbonization for everything, incentives, you know, and to meet the climate goals of the states and the federal government.
Yeah, that's really interesting stuff, and I think that's probably worth a follow-up discussion because as that's developed, Massachusetts may be leading the charge here. I'm not sure if there are other states doing the same kind of thing,
They're
but
trying. Mass
really,
is trying.
really compelling. Yeah.
So yeah, I mean, if the audience, I will offer this, if the audience is interested in a deeper dive into the building science behind the HERS rating and really diving in deep, you know, we could, I'm more than willing to come on back.
That's great. You know, close us out, Addie.
Thank you. I really appreciate everyone joining us today. It's been great. And we'll look forward to seeing how all these building codes evolve in the next months and years.
Thanks so much, everyone. Feel free to dig into our website for additional information and resources. We've had a couple of things in the chat. I believe this has been recorded. Most likely that we'll get a link to that for those that couldn't attend to the entire thing or came in late. And thanks again, everyone. See you next month.
Thank you. Bye.
Thanks.